Hello, this is another example I want to post for rectilinear motion. So hopefully by now you're getting the hang of how to do these problems, but I thought I'd throw another one up there and its solution if you need it. So here we have a car, the Gremlin, which is my car that I like to use. And we are given that the acceleration is equal to zero point 0.8 times the root v squared plus 49. So we're given that acceleration is a function of velocity. And we can also see that x, what we're asked to find is that what is x when the velocity is 24 feet per second, and how fast or what is the velocity when x is equal to 40 feet. So we know we're starting at rest at time 0, x equals 0, and velocity is 0. So the first thing you want to do with this is say, okay, what relationship do I want to use? Well, it's a function of velocity, and I need to know position. So I'm going to pull out my VdV equals AdX. All right. So if I rearrange that, I get dx equals VdV over A. So now separating or putting in variables, I have dx from 0 to x, and that's going to equal the integral of v dv over 0.8 times the square root of v squared plus 49. All right. And that's from 0 to v. So not a super simple integral, but not a difficult one. So we're going to use u substitution for this. So I'm going to say that u is equal to v squared plus 49, and du is going to be equal to 2v dv. All right. So therefore, I know that du divided by 2v is equal to dv. So I'm going to go back in, and this will then reduce to x on this side equals, and I'm going to pull the 0.8 out, so 1 over 0.8, and then that's going to be from 0 to v, and I'm going to have v du over u to v. Okay, so you've seen this before in your calculus class, but I just thought I'd go through this one. So if we simplify it further, we get x equals 1 over 0.8, and then that's again 0 to v, and we get 1/2 u to the minus 1/2. Since our v's cancel, makes life easy. And then, of course, du. And so our final answer is just going to be, actually, we wrote it in the next column. Sorry, it's getting tilted. Right at the next column. It's going to be x equals 1 over 0.8 u to the 1/2 evaluated from 0 to v, which ends up giving us x equals 1.25 times the square root of v squared plus 49 evaluated from 0 to v. All right. So if we go ahead and plug this in with what we know, because remember, what are we trying to find? We have this relationship. So our final x value then is x equals 1.25 times v squared plus 49 all to the 1/2 minus 7. Okay. And so once we've done that, then we can go ahead and solve, because we have given, remember, what is x when v is 24 feet per second. So we can plug in our respective values. And so if we plug in 24 for v squared, then we get 22.5 feet. So x is going to equal 22.5 feet when v equals 24 feet per second. So just in case you're wondering where the 7 came from, remember that when we plug in v here, we get this term, 1.25 v squared plus 49, right? And then we subtract it from this term with 0. So if we plug in 0 for this, we get the square root of 49, okay? And probably what I should have done, yeah, and I factored out I think what I did is I factored out the 125. Or the 1.25, yeah, because otherwise it'd been 7. So that should be what you have. You get to 22.5 feet. So now what we can do is we can take this same relationship and we can, because now we know the relationship for v as opposed to x, we can say, well, what is the velocity at x equals 40 feet? So really what that is just going back algebraically solving. So we have our x equals 1.25 parenthesis v squared plus 49 minus square root minus 7. So there's my relationship. Now I want to solve for v. So v squared is going to equal 7 plus 0.8 x squared minus 49. All right. So I skipped a few steps, but that's just an algebraic manipulation to get from that. So 7 plus 0.8x all squared minus 49. And then we can take the square root of that, or we just plug in our value for x. So plug in 40 for that and solve, and we end up with v equals the root of 1472, or v equals 38.4 feet per second. Okay. So I would encourage you, depending on your level of comfort with both calculus and algebra, I would encourage you to, double check, make sure you understand the whole process I did. Try the algebra here. As I said, I'm not testing on algebra in the class, but it doesn't mean you won't have to do it at all. If it's a little rusty, then practice it. So otherwise, hope this makes sense, and I will see you in class. Thank you.